Hi, my name is Nicholas Espinal. This is the eighth question on my Chapter 23 quiz, and this is what it asks. This is a true or false question, and it's asking if the electrical potential in a region is constant, the electric field must be zero everywhere in that region. The correct answer is true, and the first thing we need to ask ourselves is, what is electric potential? Electric potential is the charge Q times the electrical field E times R, which is the distance from Q. Now, there's also a negative in front of it, but from what we know, the charge isn't going to be changing value. In the questions that were given, the electrical field is not going to be changing either. But what is going to be changing is R. And when R changes, U is going to change. So that means that the electric potential U is going to be dependent on R. So that means that we can actually make a function of the electric potential on R, and we still have this equation. And when they say that the electric potential is constant, that means in terms of this equation that the change in this equation is going to be zero. And when we go back to calculus, the change in a function is just going to be the derivative with respect to the independent variable. So, in other words, the derivative of u of r with respect to r is going to be zero. That's what it means when the change is zero, or in other words, the potential is going to be constant. So we're going to derive the function that we had earlier, negative q e times r, with r being the independent variable. R is to the power of 1, and the derivative of that is just going to be 1. And we're going to have 1 times negative q times e. That's going to be the derivative of the function. And we're already told that the derivative of the function, or the change in the potential, is 0. In other words, the change in the potential is constant. There is no change. So we have these two formulas really for the derivative, and all we're going to do is just we also have to realize first is that the charge has to have a value. The charge cannot be 0. If the charge is 0, then it doesn't have charge in the first place. So the only thing we have left to make 0 is going to be the electric field. As we'll see, we're going to equate these two since they're both equal to the derivative of the function, 0 being 0 change, or a constant value for the potential, and negative q times e, which is the derivative of the potential function. We're going to notice that 0 is equal to negative q times e, but e is the only value that can change. And in order for the product of negative q times e to be equal to 0, and we know that q cannot be 0, e, the electric field, must be 0. So the correct answer is true. The electric potential in a region being constant, meaning the derivative is equal to 0, which is also the derivative equal to negative charge times the electric field, where the charge cannot change, the electric field must be 0 in order for the electric potential to be constant. Thank you.